This bug almost destroyed Microsoft Azure. Imagine if a single click could bring down an entire cloud service, allowing attackers to take control of applications, deploy malicious code, and wreak havoc on countless business. I am Mohammed Hazem from Egypt, Mohammed Hazem02 on edX and Mohazem02 on GitHub, recording this video at June 29th, 2024, and this is the story of the EmojiDeploy attack, a critical CSRF vulnerability in Kudu SCM that put Azure services at risk. I picked this topic to show how severe the CSRF vulnerabilities can be, and to prove that even the biggest companies in the world are not immune to it. In this video, we'll dive into the details of this vulnerability, uncover the technology behind it, and share how it was exploited. Our story begins with Kudu Source Control Management, SCM, the hero behind Azure App Services. Kudu SCM is a web-based Git repository manager supporting the deployment and management of code. It powers Azure Functions, App Service, Logic Apps, and more. Administrators can manage Azure applications from the SCM panel, which uses Kudu, and which requires Azure Active Directory or AAD authentication. The SCM panel is deployed by default by the App Service, Function Apps, and Logic Apps Azure Services, which is too many. But behind the scenes, a storm was brewing. Cross-site request forgery, CSRF, is an insidious attack where an attacker tricks a victim into performing actions they did not intend to, such as deploying malicious code. The heart of our story lies in a specific CSRF vulnerability within Kudu SCM, a vulnerability that could have brought Azure to its knees. The vulnerability was discovered in the way Kudu SCM's API handles request validation. Instead of using CSRF tokens, which are standard in protecting against such attacks, Kudu SCM relied on the origin header to validate requests. What does this mean? The server checked if the request origin matched the expected domain, for example, scm.azurewebsites.net. However, the attackers found a clever way to bypass this check due to a poorly implemented regular expression, as we'll see. They discovered that the same site attribute for the SCM panel's cookie was set to none, as you can see in this picture, meaning that no protection was being offered against cross-origin attacks, and that the SCM server would accept requests containing special characters, leading to cross-origin protections bypass. This finding allows an attacker to create a wildcard DNS record for his own domain and send cross-origin requests with special characters that eventually will be accepted by the server origin check. Our attackers realized that by adding specific characters like the $, the dot, the quotation mark in certain positions, they could bypass the server's origin check. For example, let's take a look at this URL, scm.azurewebsites.net._.attacker.com. This could slip through undetected. The dot acted as a subdomain, fooling the server's regex into accepting the request as legitimate. They call this attack EmojiDeploy because part of the bypassed URL, the dot_dot, looks like an emoji and it sounds cute. But here where it gets even more intriguing. One mistake alone is rarely enough to cause a catastrophe. The full EmojiDeploy attack wasn't just about a single mistake. It was a symphony of errors and oversights that came through in a perfect storm. First, there was a same-site misconfiguration. This initial misstep created a crack in the armor. Next, the origin check bypass, which we just discussed. The attackers cleverly sidestepped the server security checks with their craft URL manipulation, as we just showed. And finally, the exploitation of a vulnerable endpoint. They targeted the API/zip-deploy endpoint to deploy their malicious code directly. By combining these techniques, the research team achieved remote code execution, turning what seemed like a minor issue into a full-blown security breach. This part of the story highlights a critical lesson in cybersecurity. It's often the interplay of more than one factor or multiple vulnerabilities that leads to a disaster. This was the breakthrough they needed. With this knowledge, they crafted a sinister plan The attackers exploited the API/zip deploy endpoint, which allows direct deployment of the compressed files to the server. Then they prepared a malicious HTML file and hosted it on their crafted domain. Then they sent the link to their unsuspecting target. As soon as the target, who was logged into their Azure account, clicked the link, the malicious zip file was deployed. This led to remote code execution (RCE), giving the attackers control over the victim's Azure application. Let's make things clear and take a look at this GIF by the Ermetic Cybersecurity Lab, who actually discovered this vulnerability. The EmojiDeploy attack can be performed via a browser, but the exploitation of the vulnerability requires for the attacker to have SCM, as Ermetic have stated. Let's witness this attack in action. Here we see the attacker sending a seemingly harmless link to the victim. The victim, unaware of the lurking danger, clicks the link. Instantly, the malicious zip file is deployed and the attacker gains control over the Azure application. This real-time demonstration highlights the gravity of the EmojiDeploy attack and the sheer brilliance behind its execution. But every story has its lessons. To prevent such CSRF attacks, we can use an anti-CSRF token where every state-changing request should include a unique unpredictable token. Or we can set the cookies with the same site attribute to prevent them from being sent with cross-site requests. As you recall, it was set to none in our example, but the solution was simply that the same site attribute was changed to lax or LAX, and now cookies are not sent with cross-site sub-requests, like loading an image, for example, but are sent when the user navigates to the URL from an external site. This vulnerability was reported to Microsoft in October 2022 and was addressed in December through a stronger origin checks on the server and by changing the same site cookie value to LAX. Microsoft awarded a $30,000 bug bounty for the issue. The EmojiDeploy attack serves as a stark reminder of how a single vulnerability can jeopardize even the most robust cloud services. By implementing the recommended defenses, we can mitigate such risks and protect our applications from malicious exploitation. Thank you for joining me on this journey through one of the most fascinating and alarming cybersecurity stories. Special thanks to the CS50 staff and all those who waited to the end of the video. I hope you enjoyed it, and thank you very much.